Hello students, welcome to the video on module 5. So in this module, we will be discussing about what is meant by fabrication of PN junctions. In that, we will be seeing the different processes like thermal oxidation, diffusion, rapid thermal processing, ion implantation, chemical vapor deposition, photolithography, etching and metallization. Also, followed by this, we will be discussing about the integrated circuits and what is meant by IC, evaluation of ICs, CMOS process integration, integration of the other circuit elements. So here coming to the fabrication of PN junctions. So fabrication is nothing but forming a PN junction. How it is formed? So the basic for the PN junction formation is the crystal or the wafer, which we will be using it as the base substrate. So to generate the substrate, the first process is the crystal growth. So we will be having a polysilicon material which will be condensed or it will be converted to the seed crystal. So then we will be having how to form the crystal is which is given in this next diagram, that is melting of the polysilicon and then doping, that is you will be having the polysilicon along with the introduction of the seed crystal. The seed crystal will be dipped and then by chemical process the crystal will try to will be growing. So after that the crystal will be pulled out and then it will be formed or it will be cooled down with to form the solid crystal. So the single solid crystal which is come will be getting trimmed and then the diameter will be grinded and then we'll be going for flat grinding. Then we will be having it as a wafer. So the wafer is nothing but the flat or very of micrometer, very thin material of some micrometer thickness, and then it will be going through further process like lapping and polishing, and then it will be finally inspected to get back to get our original silicon wafer. So this silicon wafer forms the basic for all the process which is involved in the IC fabrication or in the PN junction formation. So here the first diagram gives the wafer and the second one is an ingot in which it can be sliced to different wafers, and all the process whatever is carried out in the fabrication should be in a clean room. So this third image gives the clean room which is used for our fabrication process. So the first step, so okay, I have got a crystal. What is the next step? So I want to have an silicon dioxide. Silicon dioxide plays an important role in PN junction fabrication. The function of the silicon dioxide is multi-purpose. That is, first thing is it is used in bipolar and MOS transistor. That is in the fourth module. In the previous module videos, we have discussed oxide, that is silicon dioxide, or this it acts as an insulating layer and it is used to isolate one device from the other. Also it protects the junction from moisture and other atmospheric contaminants. It acts as a barrier or it acts as a mask against the diffusion or the implantation of the impurity dopant in the substrate. Finally, the mask also allows the properties, the electrical property of the silicon will be varied due to the applied silicon dioxide. So various different active and passive components can be built on the same piece of the substrate with the help of silicon dioxide. So to generate this or to produce this silicon oxide, the first process involved is the one thermal oxidization. So what is meant by thermal oxidization? So in VLSI, thermal oxidization is a way to produce a thin layer of oxide on the surface of the wafer. Thermal oxidation may be applied to different material, but most commonly it involves the oxidation of silicon substrate to produce silicon dioxide. So when I produce thermal oxidation, there are some disadvantages too. That is, even a small amount of impurities or contaminants will clearly it will alter the properties of the silicon. So it is necessary to operate it in a very clean room. And the second one is particle filters are used to ensure that the airflow in the processing area is free from dust. So we have to be very cautious when we go for the oxidation process to remove the dirt. And all the personnel must be protected, must protect the clean room environment by wearing special line-free cloth that covers a person from head to toe. So even a small contamination is not permitted here in this process. So what is thermal oxidation? So here the silicon reacts with oxygen to form the silicon dioxide. It is used to speed up the chemical reaction. To form the silicon dioxide, we will be carrying out the process at a very high temperature, and also as we discussed, it should be done with an clean surface, very clean furnaces. So that furnace temperature will be from 1000 or to 1200 degrees Celsius. Now, the oxygen used in the reaction can be introduced either as an high purity gas or as a steam. That is, we have two types of oxidation. One is called as dry oxidation, and another one is called as a wet oxidation. Dry oxidation is nothing but using an oxygen gas, we will be reacting with the silicon. Whereas in wet oxidation, a steam will be used for the oxidization purpose. The selection of oxidation technique is used to be used whether wet oxidation or dry oxidation is depending on the oxide properties and also how clear or how thick the thickness of the oxide layer requires. So based on the requirement, we will be going selecting either dry oxidation or wet oxidation. So what is dry oxidation? Dry oxidation uses oxygen. So Si plus O2 gives SiO2. So the silicon oxide will be formed by passing an oxygen gas through the silicon which at a very high temperature. So the silicon will directly react with the oxygen molecule to produce silicon dioxide. This type of oxidation is best for all the thin oxide layers with low charge at the interface. That is, wherever we need thin oxide layers, dry oxidation is used. Also, it is preferred process when contamination is of a concern. Then the characteristics of dry oxidation is slow growth of oxide. It gives high density and high breakdown voltage. So what wet oxidation is the same process in which a steam is used instead of the oxygen gas. So here the water in the form of steam reacts with silicon to produce silicon dioxide and the hydrogen gas. So the process is used to produce thick oxide layers with relatively low temperature and high pressure. The normal temperature used for this process is 900 to 1000 degrees Celsius. So in this thermal oxidation will result in fast growth even at low temperature, and the quality of the oxide will be less when compared to that of the dry oxide. So the next we will be seeing the procedure. So here you will be having a furnace which will be of highly pure, and then in which we will be having the silicon wafers placed horizontally. So this furnace will be heated to a very high temperature, and we can have the different gases which will be flowing through this. So the thermal oxidation begins by placing the silicon wafer in the quartz rack, and it is called as the place where it is kept. This is called as the boat, which is heated in a quartz thermal oxidation furnace. The furnace consists of a quartz tube in which the wafers are placed, and then for heating there are several heating zones, and for chemical supply multiple pipes. So the temperature in the furnace may be between 950 to 1250 under the standard pressure. Quartz glass has a very high melting point, and thus it is applicable for high temperature process also. A control system is needed to keep the wafers with about 90 degrees Celsius at the desired temperature. The oxygen from these gases then diffuse from the surface of the substrate through the oxide layer to the silicon layer. The oxygen is led to the wafers in gaseous state and reacts at the wafer surface to form silicon dioxide. The composition and the depth of the oxidation layer may be precisely controlled by parameters such as time, temperature, pressure, and gas concentration. The high temperature increases the oxidation rate, but it also increases the impurity and the movement of junction between the silicon and oxide layers. These characteristics are particularly undesirable when the oxidation process requires multiple steps, as in the compass ICs. A low temperature produces an oxide layer of high quality, but also increases the growth time. So here in this video we have discussed about the thermal oxidation process. So thermal oxidation is nothing but the first step of the IC fabrication, where we need silicon dioxide. Silicon dioxide is used as an insulating material, and to get this silicon dioxide we will be using a silicon wafer oxidized by two processes. One is wet oxidation and another one is the dry oxidation. So the main concern here is the purity and the high temperature needed to get the chemical reaction done. So in the next step, in the next video, we will be discussing the other process. Thank you.